Hello judges, we are Team Trackbound and today I will be pitching an idea which aims to solve the problem of navigation for railway stations, facilities and locations. So what is the problem? The problem is that railway stations are complex environments with numerous facilities and locations such as ticket counters, platforms, restrooms, food courts and waiting areas. Passengers often face difficulties in navigating these spaces, especially in large or unfamiliar stations. Efficient and user-friendly navigation systems are crucial for improving passenger experience, reducing congestion and ensuring timely travel connections. Here we see the plea of a user who thinks, why can't he just use the Maps app to navigate around the station, which he in fact just used to get to the station in the first place? Why can't we have an indoor navigation system like we have for the outdoors? This is the state of navigation in railway stations currently. Currently, we have a non-interactive system which revolves around paper maps, A or B, asking for directions from other people. What we believe that the future should be, it should be interactive and easy to use. The navigation system should be also personalized so that even the common man may be able to use it. We present our solution, which will implement an app which will help us solve this problem. Basically, our solution is an app which implements augmented reality based turn-by-turn navigation, which upon searching for your location, you are shown a map in which arrows appear and it leads you to the final destination. And along with this, we also have voice assistance, which guides you through the turns. And along with this, we want to have integration with the SITC app. So that will allow us to have a chatbot from which the user can ask queries about the train, about the platform, or about the station in general. So how will this system work? The system will work basically, we will have periodically placed QR waypoints all across the station in the start, in the beginning, on some of the pillars, on the shops, etc. So the user can scan any of these waypoints to get started. After the QR code is scanned, we will be able to start the navigation and the navigation will appear as arrows. You can search for your destination and then the destination appears as you go in the form of the arrows on the route in the augmented reality system. So these are some mock-ups of how our app will look. For the technical approach, we have chosen, for the database, we have chosen Firestore or MongoDB, which will store all the waypoint-related data, the route data, the map data, and the QR code information. For the backend, we can choose any Python-based framework like Django, from which we will create our own REST API. The app, the front end, will be made in Unity, which will allow us to do the augmented reality part and make it look professional. And for the sensors, basically after scanning the QR code, the phone will be able to track your movement using the gyrometer, accelerometer, and magnetometer sensors, which are present in almost every smartphone these days. We are not using GPS as the accuracy of GPS is low, approximately 8 meters or worse. So it will not be good enough to handle indoor navigation. We will use the Google text-to-speech AI API to get the lifelike navigation for our voice navigation system. And also we will try to use the IRCTC app API if it is available to interact with their data. For the feasibility, we have the location accuracy should be good according to our testing, in which we will have the QR code waypoints and the tracking. We might also want to implement Wi-Fi triangulation to improve the accuracy further. The QR codes and the motion sensors ensure that they keep on the correct route. We are also trying to find a solution to the tampering of the QR codes. For example, if somebody tampers with the QR code, we can mitigate this by incorporating Wi-Fi triangulation or some form of basic GPS. And also, instead of the waypoints being QR code based, we can think of the waypoints as Bluetooth based devices, which will be implanted everywhere. So you don't even have to scan them. They can just automatically work as soon as you open the app. So the impact and benefits of this app can include increasing the operational efficiency. So it can decrease the congestion since everybody is moving faster and getting to their location easier. And it reduces the burden on the staff for the directions. It improves the accessibility. So if somebody is disabled, they will have less of a hard time getting around the station because now they can just use the app and not have to ask for help or ask for navigations. Now, the passenger experience will also be better because there will be less stress and confusion in the case of if somebody is trying to catch a last-minute train and they're getting late. Now they just know to use the app and get to this platform fast. And it will also reduce wastage in the case if we replace a physical-based, paper-based maps. Yeah, thank you.